Join discord.gg/flatearth and enter a check-in room. Someone will come along and verify you to get involved in the conversation about our Earth.
And I can't wait.
Welcome to the panel, Jake on the plane.
Jake on the plane.
I mean,
wow, you guys actually unmuted me. I can't believe it.
I did.
why?
I am muted.
Because the last time I engaged, I got muted within 3 sentences.
Because you know,
we're not worried.
What did you say? What were those 3 sentences?
Oh, I was challenging Witsit on some of the nonsense he was talking like a week or two ago.
Oh, so you
Witsit's
targeted
not
somebody.
here, though.
Yeah, that's probably a reason.
Witsit's not here right now. I am, though.
So anyway, you guys completely misunderstand this temperature stuff when you guys say, "Oh, look, the temperature of the thermosphere it's going to melt the metal on the satellite."
No, we're not worried about temperature right now,
tell
Jake.
Tell us what
that was in 2017.
Jake, who is Witsit?
Hey, who cares? Let him answer the
no
question.
one cares.
What do we misunderstand?
You're misunderstanding that the measure of the temperature of the thermosphere does not directly translate to how much heat you're able to put into an object.
Because of some fairy tale?
Then how did they measure the temperature?
No. It's the temperature of the average kinetic velocity of the molecules that they're interacting
with.
Measure
that?
Okay, how do you prove that? How would you prove that?
It's extracted. It's actually extracted from the orbital decay data of satellites.
There's nothing wrong with that. Listen.
What does that even mean?
But what's wrong with that? Seeing is that things are made of molecules and they're getting blasted by the direct thermal energy of the sun. We're not really concerned with what the weather would feel like up there, in all honesty.
You mean the direct thermal energy of the sun? So those temperatures that you're seeing in the various layers of the atmosphere correspond to the average speed of the molecules. But because in the highest part of the atmosphere, those molecules are being hit. They're being hit by particle radiation from the sun in the form
how
of the
fuck do you know that shit?
They're accelerated.
You know that,
citation, source, and demonstration, brother.
Yeah.
You're breathing a lot of hot wind over here, man. What the fuck?
Yeah, I mean,
I got real questions. So is the 4,300 degrees Fahrenheit? Is that the ambient temperature?
That's the temperature. That's the average temperature in that region, which is actually a measure of the average kinetic velocity of the molecules of atmosphere.
That's why I asked you how they measure that.
I just told you because of the fact that the atmosphere is so thin. There's so few molecules per every cubic meter of atmosphere. You can't use a conventional instrument to measure the temperature like you can't use a thermometer like you would here.
But aren't they going very fast?
I'm sorry.
It's just a story.
Aren't they going, Sonny? Hold on, dude. Please, everybody, stop interrupting me for a second. Aren't they going very fast?
Yeah, they're going very fast. They're in orbit.
So that argument holds no water.
What do you mean it holds no water?
Because they're impacting the same amount of molecules because they're going faster.
The same of molecules compared to what?
Being at a lower elevation, right? That has more molecules per unit per volume, right? Because they're going faster, right?
But the atmosphere,
they're going through a larger volume of molecules because they're going faster. Do you get it? Right? Why is a hypersonic?
That's true. But when you're talking about the altitudes where you're considered in space, right above the Kármán line, it's still almost nothing as far as atmosphere is concerned. So even though you're running into a lot more molecules because of your speed, it's still far. It's not anything. It's not anything that you would like. You could stick your hand out and you would feel it on your hand like you would driving at 20 miles an hour in your car.
So that's what's interesting. So the molecules that are there.
The orbit is still decaying.
I'm sorry. I thought
it's very slow.
I waited for you to finish so I could talk.
Yeah. Well, I wasn't done with my interrogation. So.
Oh, okay. Go ahead.
I have one more question. Well, how did they know? How did they differentiate the temperature, the ambient temperature, from the temperature created by their motion?
How did they differentiate from the temperature? There is no temperature created.
Of the environment. The environment they're in has a temperature. You said it's because of the kinetic energy of the molecules. But they also they're imparting a kinetic energy from their motion, right? So how did they differentiate the one from their motion versus the one from the ambient temperature of the particles?
They do some. I don't know the specifics on how they do it, but I know it's derived from it. They have some way that they work out the math that they derive from the orbital decay of the vehicle, which is the only way that they're able to measure the temperature.
Yeah, sure.
At those elevations, because there's so few molecules to interact with. That they can only calculate temperature, quote unquote temperature, through a non-direct means, so to speak.
Yeah. Okay.
It has to be interpolated from the orbital decay data.
That's a cool story, man.
I mean, the science behind this is pretty complex.
Maybe if there was less air, they would have more kinetic energy, or if they have more air, then they would have less kinetic energy, and you'd get the same result. So basically, you're just fucking guessing and making up bullshit. I'm sure you believe what you're saying, but there's no evidence for it. And you just saying, there must be doing calculations out there somewhere because it's true, because I saw a diagram on fucking Google. That doesn't mean anything to us. We want the actual experimental data.
Yeah, I'm sure there's lots of papers written on it, but you guys wouldn't accept it, right? Because you guys would say, because you didn't personal. Okay, so if I go and I find you a data showing exactly how they measured these temperatures in orbit, are you going to then say, well, this is all nonsense because space is fake and they lie about space and NASA lies?
Because it's not theoretical.
Are you going to accept the paper and the data that's in the paper?
Because
the data is not theoretical. The data is derived.
Where they would not be able to differentiate one from the other. They would not be able to differentiate the temperature from the what would you call it? From the amount of gas, right? Right. So you have the amount of gas that's in the volume, and it has a temperature. Then you have your speed. Well, in the so-called orbital decay. So you're going to infer, okay, we're decaying this much. That means that we're getting hit by particles with this kinetic energy. Well, you also need the particles per unit volume, right? So either one of those, you could, like parameters, like sliding scales, you can slide one up and slide the other down. You could go up more particles and down temperature, or up temperature and less particles. It's impossible to differentiate unless, I guess, you stick a freaking, a soup can or a jar outside the window and close the cap and then count the number of particles in that. It's theoretical nonsense, man. But, you think it's a gospel truth, and for some reason we're afraid that you're going to bring it up. Why wouldn't we be afraid of that?
You have to assume the Earth's diameter to get into orbit, and you need elevation angles using a horizontal.
Well, we know the radius of the Earth because it's been measured many times, so that's just silly.
It was measured using what device?
What do you mean measured? What do you mean using what device?
Measured with? You don't use a device to measure things? Good God.
Yeah. There's many different methods to do it. The easiest of which would be to measure it with measuring how much vertical plumb lines move with distance.
Vertical plumb lines?
Right.
Moves relative to what?
Relative to each other. Because plumb lines on the Earth are not parallel, right? As has been demonstrated by countless surveyors, as Main Surveyor has demonstrated in many debates, as Jesse Kozlowski has shown and measured in many debates.
That's not what Ruhiv said.
I don't know about Ruhiv. Ruhiv is a software millionaire. He's not a geodetic surveyor.
Neither are you. So what?
Neither are you.
No, but I've looked at the data that was presented by them, and no, vertical plumb lines are not parallel on the surface of the Earth.
Yeah, you looked
when you add up the angles, you can see that vertical plumb lines are not parallel, and they will tell you what the R value is because they follow a certain amount with distance.
Never been directly measured.
Now you're making. Hold on, son.
Why is that not a measurement? That is a
Hold on.
direct measurement.
Now you're making shit up, Jake.
What do you mean I'm making shit up?
That you can measure the radius using deflection, using zenith angles. You're making shit up.
Well, why wouldn't you be able to measure the Earth with zenith angles?
Because there's something called deflection of the vertical.
What's deflection of the vertical?
So in the globe model, plumb lines curve.
How do plumb lines curve in the globe model? Please explain.
Here we go again.
You claimed main surveyor.
Meme. Here we go again. Oh, shit.
And you're the one that claimed main surveyor. He's the one that spells that bullshit.
In the globe model, plumb lines are not perpendicular to the perpendicular to the surface of the Earth. They are deflected randomly.
Are you talking about the minor deflections of nearby masses? Like if there's a mountain nearby, there will be a minuscule deflection of the plumb line. Are you talking about things like that?
You mean the 0.71 degree minuscule deflection? That one?
Where is it 0.71 degree relative to what? Show me the measurement.
Well, hold on. Show you the measurement. It's well known. Well, I would
0.71 degrees be in 10 miles.
It's the largest one I've ever seen. It's not minuscule.
Do you have that image in the hopper, Indio?
Oh yeah, I can just scroll up a little bit because we just did this.
Yep.
You're saying this is main surveyor's data, right? So show me the plot.
Listen,
the plot that he produced showing the 0.71 degrees.
I'm showing you geodetic surveying. Only retards on YouTube that are surveyors say that they're measuring radius from vertical deflections. Yep. Nobody else in surveying says this.
It's amazing, Jake.
Only anti-flat earthers.
This is from.
Yep.
You can just type in Google too. You can just type in a deflection of the vertical or curved plumb line surveying, and you'll get lots of images like this. See that curved line? That curved line is the plumb line.
And you asked for Ruhif, he just popped up in the chat. Oh, fuck.
So what are you actually measuring? So what are you measuring with these reciprocal zenith angles? Not a goddamn thing, man. And here's a problem. Here's the other problem with them. Because I know, so I talked to Main Surveyor and I talked to Jesse Kozlowski. When I told Jesse Kozlowski about this, he said, stop posting on my YouTube channel. When I talked to Main Surveyor about it on Twitter, he blocked me.
So, probably because you're taking something he's saying out of context. I don't know. I don't know why.
Oh, that must be it. That must be it. Obviously.
Like the image
I don't know.
Posted. Well,
I know you don't.
Yeah, but it depends on what the context of this image is.
Yeah, it depends.
Can you show me the source? Can I read the original paper that's from, so I can read the context of that?
Yeah, there's plenty. There's plenty, man.
I'm going to start applying the sextant to this. How do you Globers get a freaking level?
You know what's funny though, in your
horizon
is that you have to be handing out the anti-flat earthers this information when they should already come prepared into the chat with us.
Yeah, you should know your own model or something.
That's weird.
Yeah, excuse me for not knowing every detail of every aspect of everything.
Well, that's what happens. That's what happens when you come in half cocked, Jake. You think you know what you're talking about.
Ruhib is asking to be unmuted. Will he be unmuted?
Yeah, but he disagrees with you, so we're not going to talk to him right now.
Well, let him. Go ahead. Let him. He kind of looks like Vanilla Ice in that picture, doesn't he?
Whatever. Who cares?
I agree with you.
How do you get a zero level with your sextant with a curving plumb line?
I didn't say a sextant. I said like
I did. Yeah, you're right. You're right. Yeah. Why would you think you said something that I said? Yeah, I'm the one that said it. What the fuck?
Yeah, but you wouldn't use a sextant for this. You would use a theodolite with an auto level built in.
This is your freaking model, bro. Not mine. Yours.
What does an auto level do?
How do you get level with a curving fucking plumb line? Tell me right now.
Wait, what did you just ask me? Sorry, my wife was talking.
Tell me, how do you get a level with a curving fucking plumb line? That's what I said.
What do you mean? We're talking about local level at
I don't give a shit. Show me how you get a level with. Show me how you get a fucking level with a curved plumb line. Show me right now. Right now.
Yeah, that plumb line. If there's curvature in that plumb line due to magnetic with minuscule magnetic deviation, they're going to be different at different levels. But you'll have a level line at any discrete point along that line.
Jake, shut the fuck up and show it right now in the voice.
That curvy line is incredibly exaggerated. Is going to be.
Shut up and show it right fucking now, immediately, right now.
Well, so the funny thing is, you came in here with evidence. Your evidence was deflection of the vertical measures the radius. First of all, that's not a measurement of the radius. That would be an inference that there's a radius of some value. It wouldn't be a measurement of a radius. Okay? You'd be inferring that from a different measurement. It'd be called an indirect measurement. So it's not a measurement of the radius. Secondly, you didn't know the details of the operation in the gold model, like what the gold model actually says about what's happening. Okay. And you said to us, well, I don't know every detail. Then why is it like evidence, dude? Why didn't you look up every detail before you presented it to us?
That's what I'm wondering.
And I'll find a source of that image.
This deflection, by the way, I'm looking at one of the papers on it. Yeah. This deflection.
Mm-hmm. Go on.
They're amounting to less than an arc minute.
Depends on where you are.
Just enough to run.
Why does a diagram show it in that? Why does a diagram show it exaggerated like that?
That's less than. Because diagrams are always exaggerated to illustrate the point, right?
Even with less than an arc. What did you say? Arc minute, arc second.
Yeah, less than 0.0167 of a degree when you're next to a giant deflection like a giant mountain.
Right. So so if you're up in altitude to any degree and there's any deflection, then you don't have plumb to a horizontal. Like, because it doesn't connect. It doesn't connect to the Earth in the angle in the vertical angle because there's deflection there. Doesn't matter how much. You don't have a 90 degree, and that's the point of dropping the plumb line.
Yeah, the reciprocal zenith angles are off by like arc seconds. You're saying that these plumbs are diverting by just under an arc minute. That's a huge difference.
And the farther away, the bigger the difference.
And wouldn't this also occur on the oceans? And
more importantly, though, let's say that you're doing this like I think with the one that Jesse Kozlowski did was on a lake. The local deflection there over, I forget what the distance of his measurement was. I think it was around a mile or 2 miles, somewhere between a mile and 2 miles. If there's a nearby mass, right, like a mountain, 20 miles away or whatever, that's causing a few second deflection in the plumb line, it's going to affect both measurements in the same direction.
Not necessarily. Why would you think like? Why would you think?
Yeah, because it's going to be the mountain that's causing that, right?
Okay, what if there's a mountain?
So if the deflection is away from one another, that's separate from the deflection that might be caused by a nearby mountain, right?
Okay, so you're making an east-west,
and you do this.
There's a mountain on the east and there's a mountain on the west. You think that a deflection is going to be the same unless both mountains are the exact same side, right?
Well, if we're talking about within the very, very close geographic region, within a close geographic region, and more importantly, you do this on lots of different places on the Earth, including places where there's minimal deflection, and you consistently get the same spherical excess. Then you know.
You're making that up.
I'm not making that up. What do you mean?
You are making that up. There's no measured spherical excess.
It's imaginary.
It's all over the literature in geodesy.
Yeah, you know what? I know it's all over because when they do their measurements, they do what's called reduction of the horizontal direction. And they project the measurements onto a reference ellipsoid. That's why the reference ellipsoid exists.
It's just nonsense. It's just word salad.
Page 47, bro.
There's also deflection.
Hey, Mayhem, you got page 47?
It's just word salad.
Oh, shit. I got page 19, but you got 47?
I don't know.
I don't have it on.
19.
Yeah.
There's also deflections because of the centrifugal force with the gravity, like the direction of those vectors.
Where is the? Oh, give me a second.
Plus, you got all the random anomalies of gravity all over, so it's silly.
You stand just right, your balls will separate.
What's this spherical excess? Where are they measuring these fucking angles from? They measured straight lines in from point to point, and then they put it on a sphere. That's where you get it. It's a mathematical equation. There's no reality in it.
Hold on. Reduction. I don't know how long ago I posted this.
Oh, here.
Oh, you got
page
it.
19, a fourth paragraph.
Oh, I got page 47.
Okay. Well, I got page 19, paragraph 47. Paragraph 4.
So, Jake, you're more than welcome to read this. The reduction
Mine's page 19.
Direction to sea level. Direction of the station as given in the abstract still need a small correction to reduce them to what would have been the object observed upon at the sea level. The altitude observing station difference between them does not enter into the case. The reduction is due to the circumstances that, in general, the verticals at the two stations are not in the same vertical plane. The correction, equation. Okay, and on and on and on. Okay, so the azimuth line counted from south to west, and the latitude of the place, the log is this, and it says, and the Clark spheroid of 1866, in dividing fraction by sine 1 prime, I prime, side I prime, we get for the correction in seconds in the height in meters. So they're correcting the horizontal direction. Because think about it like this, Jake. If you had an orange and you stuck 3 toothpicks in it, and you connected those 3 toothpicks. Now, of course, the toothpicks are sticking, perpendicular to the surface of the orange, and you connected them with a string, right? That would be a 180-degree triangle, right? 3 toothpicks in an orange, a triangle. I tie a string connecting them, and I measure the angles of the string. That's a 180-degree triangle. The only way I'm going to get a greater than 180 triangle, if I take that string, slide it down to the toothpick, and make sure every part of the string touches the orange. Then I'm going to have a greater than 180-degree triangle. That's what the reduction of the horizontal direction to sea level is. You're projecting onto a reference ellipsoid. That's why it exists.
Reducing it.
Why would you need a reference ellipsoid? Why use it at all? You can just go out and make measurements.
Yeah, reducing it down to a globe.
That doesn't exist.
It's just silly.
Yeah, because line of sight
it's just obvious. It's just obvious that your local horizontals are not parallel with one another. Measured all over the earth and by a consistent amount at all locations. It's the reason why we see the celestial sphere move 1 degree per 69 miles. It's the only explanation that works, except for what Bob Noto said, which is personal atmospheric domes.
Dude, you can't even. You're
full of shit, man.
Okay.
So Miggy, what causes Polaris to shift 1 degree per 69 miles? What causes that?
It doesn't.
What do you mean it doesn't?
It doesn't even in the globe model, you retard.
Of course it does. What are you talking about?
If I go from 89 latitude to 88 latitude, what's the shift? Go Google a fucking latitude.
89 latitude. What do you mean?
89
1 degree. The shift is 1 degree.
No, it ain't. No.
What do you mean? No, it ain't.
In miles. In miles. What's the distance between the latitudes in miles between 89 and 98?
It's going to be roughly 69 miles.
It's 8 miles.
What do you mean it's 8 miles? Are you talking about because of refraction? Are you talking about because of refraction when it's near the horizon?
I know why you're fucking muted. You don't know your own fucking model. Come back and learn, dude.
It's just wrong, dude. So.
Yeah, I'm not gonna teach you your own fucking model, dude.
That's the thing, though, Indio.
Look in the chat. So use that little calculator. Calculate the fucking latitude and longitude distance, right? Just change the latitude of the top part and the bottom part. I'll just fucking do it, dude. 88.
Let's do it for him.
89. Fucking spoon feed these motherfuckers.
Yeah. I'll give them the PDF that they claim as their holy script. Here it is. And that's where we got that information off of, straight off of there. Page 47 and page 19. There you go, Jake. The snippet that I took in Indio were both out of that PDF that you guys claim as your holy writ for the globe. Have fun.
The geometric figures are developed on a spheroid whose dimensions are different from those of the actual Earth. Yeah, spheroid. Mm-hmm. Yeah, you're right. They just said it right there. Doesn't match the actual fucking Earth, bro. Get a grip.
That's what I've been saying. But, you know, we just let them walk into it. I mean, take your time. Read it over and over until it sinks in. Eventually, the penny will drop, but we're not triggered, dude. It's just we have to keep teaching you guys these things. Every single time you come in here, we have to keep teaching you. Why?
And it's like
you guys should already be prepared.
The best witnesses are they're actual experts. It's hilarious. I don't get it.
Yeah, you're right, Blue Jumper. He came in here fully like guns blazing, and then he just like now doesn't know anything.
What is your profession?
See, old friend, I brought more soldiers than you did.